Hello, this is Paul from Foresight Tech. In this lecture, we are going to find the hyperbola equation in a rectangular system. So I summarize the two types here. It's very similar as ellipse we just learned. The first type is horizontal. The second type is vertical. Okay, and later we will get the standard equation. Okay, I will skip some details because this is a topic we learned before from trigonometry, right? Okay, so the first type is horizontal, which means what? Okay, we put the two focus and the two vertices onto the horizontal line, okay, x-axis. And the first we put the center to the origin. This is special type. Okay, what I graph for you is the special type. I put the center to origin, and then put the two vertices. One is negative a0, another is a0. Okay, which means what? We can determine a is the parameter from any of the vertex to the center. Right, a is this distance. The second, I put another two points is two foci. The first foci f1 negative c0, f2 c0, which means that the parameter c is the distance from any of the foci to the center. So that longer one is c. Okay, and after we put the center and they put two vertices and the two foci, and then what is the graph of hyperbola defined? It defined it in this equation, which means what? Any point P on the hyperbola should follow this equation. And this equation means the distance P to F, F2 minus P to F1, because in this is the left branch, right? So P to F2 is longer than P to F1. Okay, and then we get it. The distance is 2a. 2a is the distance between two vertices. This is a, this is a, the distance is 2a. Okay, we can see. Or if the point is on the right side, so this time you should use p f1 minus p f2, right? Therefore, both of them we put the absolute value to describe both branch. Okay, so from this equation, and finally we do calculation. We set up the coordinate, Cartesian coordinate. P is x, y, plug into this is definition, and then you can square both sides twice. Okay, and then finally you get a simple one. It's the standard equation is here because it's much simple. Okay, and can we compare this hyperbola with the ellipse we learned before? Okay, ellipse is plus, hyperbola is minus. That's the major difference you can see, right? Of course, the graph looks totally different. One more, and this special type, we put the center, put the center of the graph on origin. However, if we change the center to HK, which means shift, okay, what do we need to do? Replace x by x minus h, replace y by y minus k. Okay, h is for x, k is for y, and then this is the general standard equation. A little bit more. So let me check what the standard equation. See, and the x, this is horizontal, okay, and the x go first, right? X minus y, and later we compare to the vertical type is y minus x. That's the difference. X go first, and always a go first. A go with the x. Okay, okay, a is here. But what is b? We did not define b, right? So we need to define b. And the c and the c, a we know. Where is b? B is came from this rectangle. Okay, came from this rectangle. B is this point on the minor axis. If we say it's the minor axis, 0b. I mean the half of the height, of this rectangle. This rectangle is important. Okay, important for us to draw. Okay, the hyperbola. So let me look at the box. So this is A, and this is B, and so we can draw this box. And if we link these two diagonal, okay, these 2 points on the diagonal, what do we get? We get the asymptote, okay. If this we get one asymptote, and we link these 2 points, we get another asymptote. Asymptote means the graph will approach, gets closer and closer to this asymptote, right? This is straight line. Okay. Asymptote equation is here, and you easily get this equation by looking at what? By looking look at this first. You can look at the slope. The slope can be found from this right triangle. Okay. Let me see what is the right triangle. This is A, this side is B, and this side, okay, keep in mind that this side is C. That's the definition for B, which means what? It's a Pythagorean. Okay, so we can get C is the longer one. C is also from the center to any of the foci. Okay, so however, this definition tells us C squared equals A squared plus B squared. If you know A, if you know B, if you know A, if you know C at the beginning, right? Definitely you know what is B. Okay. See, and the slope is B, the rise over the run. B over A is the slope for this asymptote. Okay. The same for this asymptote, of course, is a negative. They are symmetric to each other. Okay. This is the basic for the first type. Let me generally look at what the basic for the second type, vertical. Okay. First, the horizontal, you know, the open direction is horizontal, open left, right, right? So if we open up and down, this time is vertical. It's the same definition, okay? So, but something are different. And we see the vertex this time is on y-axis, 0a, 0, negative a. And the foci is on y-axis still, okay? And always toward f1 is 0c, f2 is 0, negative c. Okay, that's a little different, right? And another difference is between the asymptote. So can you see asymptote? The slope change. The original asymptote slope is b over a, and for vertical is a over b. You know what? If you draw if you draw a box or rectangle, you will see. Okay, the rise and the run just switched. So this time the rise is a, the rise is b. Therefore, the slope is a over b, and this is negative because of symmetry. And one more difference is on the equation. Can you see the equation? And this equation, vertical y go first, and for the horizontal x go first. Okay, they're always minus. And keep in mind a is always go first. Okay, with the first one, a minus b, like this. Do we know so which one is bigger for AB? Because in the ellipse we know, okay, the biggest one go with the x is horizontal. The biggest one go with the y as vertical, right? Do we know the size for AB? No, we do not know. Okay, so A always go first. But we do know, okay, among A, B, C, which one is the largest? C. Okay, among this right triangle is C, is the hypotenuse, is the longest. C is the longest. Or you can see C is the center to foci, right? Center to focus, okay, of course, is bigger than A, the center to the vertices. So if we shift, we get this equation, and then we see this is the two standard equation we can see here. Okay, two standard equation. I'll give one example. So how do you use these two? Okay, either one. So to get the standard equation. Can we see this question? We need to find the equation for hyperbola. We have two bunches, and they give it the foci and the two focus, and they will give you two vertices. So we have to find what we need to do. The first step, I still need to draw a graph, right? So I draw a basic graph so you can see, and the graph will help us to determine what the parameter. First, what the type, okay, is horizontal or vertical, and then to determine what is the parameters. Okay, so we need the Cartesian system. If I simply draw this y and this x, and the foci is 5. Okay, so if I put a 5 here, -5, right? -5 I put it here. So this is two foci, and then two vertices. 2, negative 2 for x, right? X coordinate. If I say 2 is here, this is a 2, the negative 2 is here, negative 2. And you see, okay, now you know what the type. Do you think it's open, up, or down? No, it's open, go through the vertices, and open toward the focus. This is the focus. So we should go to left, open to right, right? Okay, so now I draw the graph. You know the graph just simply look like this, right? You see like this, okay? Probably it's okay, just a rough. They give you an idea. And these should be very symmetric, right? So like I simply draw. Okay, so probably you can see. Okay, and our graph look like this, which means what? Which type? At least we get it. Should it be horizontal type? Okay, so first we determine it's already horizontal. If it's a horizontal, and we can make the standard equation, right? So we'll copy the formula. So standard equation is what? Horizontal x go first. Okay, keep in mind that x go first like this. X minus h square over, always a go first, a square, minus, which is different from ellipse, and then y minus k square over b square equals 1. This is the equation I copied. That's the standard equation formula. Okay. Now we need to find the parameter a, b, and the hk. I'll find the hk first. What's the hk? Hk the center. Easy to find it. Did the center, right? Okay. Did the center hk. What this? By symmetry, this should be 0, 0 origin, right? Good. So we find the center. So the center is hk, which equals 0, 0. hk is 0, 0. Now we go to AB. I'll go to A first. The definition of A is what? Is the distance from the center to any of the vertices. If I show this distance is A. Okay, this distance is A, which means A equals 2, right? Good. I get A equals 2. Keep in mind A is a positive number. Okay, A equals 2. Where's C? Or where's B? We don't know B. Okay, but we do know C, and then we use the relationship. So where's C? C is the, if we go into the definition, C is this. C is the distance from the center to the focus. Okay, any of the focus. This is C, right? And the C is 5, definitely. So we find the C is 5, and then we can definitely find the B. Do you remember the relationship? B square, A square, C square. Okay, put together. Which one is the biggest? C. Okay, is the biggest. So B square equals C square minus A square. Okay, go back to the Pythagorean. And the C square 25 minus 4 is 21. Okay, now we have everything. All we need to do now is plug A, B, HK into the formula. So what do we get? A x minus 0 squared is x squared over A squared is 4 minus y minus 0 is y squared, B squared is 21, and then equals 1. See, this is the final equation we need. That's all. Thank you.